Thanks, Kim. So, do you understand me well? Yeah. Okay, good. So, as said, my name is Matthias Eckermann. I'm close to 19 years with SUSE. I started off as a consultant, and now I'm Director of Product Management for SUSE Linux Enterprise, which also includes part of our container business, virtualization and security my team serves. Kim already introduced this slide for the SUSE software-defined infrastructure, and I added here another sentence or some words, application delivery approach. Because what this really is about is not that we only deliver infrastructure pieces, and you do not only need infrastructure, but the end game of every IT that we are discussing is that something is done for a line of business, for a specific group of people, for an end user on the web, or an end user in-house to your institute or your enterprise. This is what we really are talking about, and so this is why SUSE has reviewed over the last years their approach of delivering software. We have started with SUSE Linux Enterprise as the operating system, and Linux is still in the heart of SUSE, and many of the good quality approaches and the software development approach that SUSE has and still applies to all of these product portfolio comes from SUSE Linux Enterprise. Nevertheless, we expand our business, and one important message that we want to have also in a very open way, I didn't understand the Finnish, unfortunately, probably Kim already said this, is that we are not enforcing anybody to use everything out of this stack. But it is a toolbox of offerings that you can match to your needs in your respective infrastructure, or depending on the needs of your line of business with respect to application delivery. So what are we seeing here? We're seeing here, starting from the operating system and the physical infrastructure, a stack of, let's say, virtualization in the first place. So software-defined infrastructure is nothing but virtualization taken the next step and into all pieces. Virtualization itself we call software-defined compute, basically. Then we have virtualized storage. We have virtualization on the networking, software-defined network and network function virtualization. And we also provide the management for such a software-defined infrastructure, which is a cloud environment. We will hear about that later more. On top of this, there are multiple methods of delivering applications. The obvious way, this is what we all do for the last, I don't know, half century, is delivering applications directly on the operating system. But there is more ways of delivering applications. Today we will hear about the SUSE Container as a Service platform in the upper left part. And this is really about managing and orchestrating containers as a way of delivering not only a single application, but a set of microservices which then build a complete application stack. And in the future, and SUSE has just started and released that, we will hear more about Platform as a Service. This is a Cloud Foundry-based solution for not delivering something to manage containers only, but primarily it is a platform where the developers and users directly go without the end user and the end developer having a need to care about the nasty details of how stuff is done in the back end. So what we also see here is a kind of abstraction from very concrete physics, where physics also might include public clouds, but that's a detail, to the operating system, abstraction level here, then an abstraction level virtualization, an abstraction level containers, and the abstraction level that we only look at the platform at the very end. And depending on where you are and what you need, you might use one or the other, you might mix and match. An important aspect of what SUSE does is, and I mentioned this also in the public cloud a little bit jokingly, is that SUSE always thinks across architectures. And internally we see the public cloud a little bit like just another architecture. So we have the Intel AMD world, we have ARM 64, fully enterprise supported, we have IBM Z and IBM Power, and we deliver all the big public clouds, and stuff runs there, obviously. This is the vision that SUSE has, and this is the portfolio that we have added up with the management and lifecycle management that we also provide. And this is where we see the customers choosing from depending on their needs. Let's go a little bit more in detail into the application delivery and what the differences are between application delivery in a more traditional way and in a more containerized way. Just imagine an e-commerce shop. The classical way how you present this, how you use this, how you architecture this, is to have a web application which is connected via an application server to a database and potentially an ERP system where you have the transactions then for the final shop. This is monolithic applications very often, and they are also using a siloed resource architecture. So you have your storage, you have your network group, you have your server group, and that's it. And very often, I have seen this in my past as a consultant, that these groups with these siloed resources even fight each other. So you don't get a network resource so easily. You have to wait a week for your network part. That's obviously where some of these ideas started to have a different approach. An e-commerce shop in a more containerized world will consist of microservices. Microservice means that you separate the monolithic applications into the minimized set of very specific applications or application sets that then work together to build this application. That's actually what Unix always has done, that you have very small tools which you use for a specific purpose, and we could see microservices as such. Very small tools with a single purpose that work together. In the same way, if these microservices build up a very single approach, these microservices, though, have to scale, and they probably need different back-end resources. And to not bind the different back-end resources to a specific hardware or software need, this is where the software-defined infrastructure that I just described before comes in. You need the flexibility also on the resource level to build the flexibility on the microservices level. The interesting aspect, and that we should never forget, is that these technologies and these approaches can also be mixed. And in most enterprises and institutions today, we see that there is a mix of those. You cannot arbitrarily transfer between those, but you can start mixing those. For example, you could say, I have virtualization, but I still have a siloed storage. That's very common, right? But you could also say, okay, now I start to replace the siloed storage with a distributed storage, with a software-defined storage, to become more flexible and potentially even save money. And this is how these things work together. And if you remember now what SUSE had done, what we had on this slide, then you see that with our approach of products and offerings, we can fit into this picture depending on how you need it. And this brings us to the changes that are necessary. Kim has already talked about this. The changes that are necessary to deploy such a microservices-built infrastructure and to replace the siloed approach by a more flexible approach has consequences on multiple layers. So you do not have consequences on the IT infrastructure layer, this is where we just were, but it also has consequences on the way how you deploy applications. We said we go from siloed, from monolithic, we go to more microservices. But if you have this, you also have to change the way how the application is architectured. So for example, you don't need a big HA cluster anymore, but you do it in a different way. You do it on the application level, that the reliability is confirmed. And this also means that you need a different development approach. You need different people, or different thinking at least, so that people do not trust the infrastructure anymore, but that the application itself trusts or builds in kind of reliability or failure safety. This means that you need a different architecture and sometimes, not always, a different approach with respect to the development process. Waterfall is very traditional. It's kind of like a monolithic application, but waterfall might be useful in some cases. For example, SUSE Linux Enterprise itself is built as in a kind of waterfall method, while the pieces of SUSE Linux Enterprise, the sub-functions like high availability or the systems management, those are built in an agile approach. Because the project is so large and so many people have to interact that an agile approach doesn't work anymore. You need small groups for this. So we have an overlay, basically, a mix and match in our own infrastructure and our own development itself. These changes, this is what sometimes analysts describe as multimodal, or mode 1, mode 2. We think that mode 1 and mode 2 is a little bit black and white, or here it is green and black. Instead, we should think about, and I try to describe this in our example, we should think about a flexible way of things going into each other. Not necessarily going back, but moving from one to each other. And as an operating system, we have not only this challenge of multimodality in-house, but we also have this challenge of multimodality in your infrastructures, because what you need from us is an operating system which works in the one world as well as in the other world. So how to achieve that? There are also consequences. Waterfall means very long processes in your infrastructure. You want to plan for the next 7 years. In an agile or even DevOps world, 7 years is incredible. 7 months is already long. 7 days is normal. So this is a complete different approach. You may need, in the one world, you want a guarantee for support of a specific version of a specific package for 5, 7, or 10 years. In the other world, it's already old tomorrow. To give you an example, there is a very famous container engine called Docker. It's one of multiple. But we indeed had 2 customers asking us for long-term support for the Docker engine, which is kind of, really? Don't you want to benefit from the development in the community for the next years? No? They really want to freeze that for at least a year, if not 3 years. And this is kind of the tension that the whole industry is in. Not only us, but it's a tipping point, the tip of the iceberg, where you see that really we have multimodal approaches which even mix in the worlds, depending from which position you come and what need you have to fulfill. So, what should an operating system do? Actually, the operating system also was monolithic in the past. When you look at SUSE Linux Enterprise 9 or 10 or operating systems at that time, you will realize that they came as one CD where you installed things from and you were happy. Later on, you wanted more, and everybody wanted more, and it grew into a DVD, and we did a little bit of a split, and we modularized. This is what happened primarily in SUSE Linux Enterprise 12, later on also a little bit in 11, because we added modules also to 11, at least 2, public cloud and security. This was a way for us to help with these different requirements. A very stable operating system on the one side, and then modules which have a little bit different life cycle and a shorter life cycle often, to keep up with the development in the communities. Now, the future is now. With SUSE Linux Enterprise 15, we built this modular approach a little bit further. So we have also kind of modularized the base operating system, which for us has the benefit that we can really use a common code base. So in former times, you had always multiple main products, and you installed a SLES, and you could not mix it with a desktop or an SAP. What we have done now is that we really build building blocks. We call them modules, but you call also like a Lego or whatever. We have building blocks which are functionally contained. And these building blocks we put together and build the different products out of these building blocks. So that, for example, you see that nicely on the SUSE Linux Enterprise for SAP applications. This actually is a combination of SUSE Linux Enterprise Server, a unified installer, I will come to that later what that means, plus specific SAP integration aspects, plus high availability, plus service offerings on top. So this is the way how we approach this in the future. The other aspect is that the same technology that we are using underneath for SUSE Linux Enterprise, this is marked with these looking very similar here, the same base OS, calling unified installer here, micro OS there, we are using for our container as a service platform. It is exactly the same kernel, it is exactly the same glibc, it is exactly the same tools. There's just one difference, which I will describe in the afternoon, with respect to updates, where those two are different. And this depends on that the one is a multi-purpose operating system, and the other one is a single-purpose container host operating system. But it's the same technology, same hardware enablement, same certifications. And this approach is what we are working on as SUSE Linux Enterprise 15. And this way, we believe, we can fulfill the requirements of traditional infrastructures and software-defined infrastructures, and we can even bridge them by, for example, providing a container runtime on SUSE Linux Enterprise server, for example, for people who want to just try a container or who want to develop containers or build containers. There's SUSE Linux Enterprise is for. But people who want to run containers in a scalable way, the container as a service platform then is the obvious choice. And this is how these things belong together. You have multiple use cases for the traditional operating system. It's your toolbox. You may use manual or automatic installation. There are multiple ways of updating, maintaining the system, and there is a high variance of which packages you choose, depending on your infrastructure that you need. For a software-defined infrastructure, the operating system can be a single-use operating system. We pre-package it for automated and centralized installation, configuration, and scalability, and it is an always up-to-date operating system, like your mobile phone is. Keep this picture in mind. I come to it in the afternoon as well. And with this here, we have from one technology an overlap and a bridge between these worlds with the same trust in the software that we are building. So it's built according to the very same principles. In other words, SUSE Linux Enterprise 15 as a platform builds the bridge between traditional infrastructure and software-defined infrastructure, and it helps us as well as our customers and partners by providing the same trust and technology. And there are three, I don't want to say themes, major principles for SUSE Linux Enterprise Server to make it a world-class enterprise operating system. I apologize for the marketing speech. And these three topics are increasing uptime. This very obviously goes for traditional infrastructures. Improving operational efficiency, it's number 2. This applies for all infrastructures. It is our task and your demand to us that we make it as easy as possible for you to use the operating system or the container as a service platform. And then there's the third aspect, helping you to accelerate the innovation on your business needs. So not necessarily helping us to innovate. We have to care about this ourselves. But us helping you to innovate and not being blocked by a too old platform or too old offering that we have. And with the example that I gave before, you see that SUSE is not in an easy position if we have customers asking for 5 years support on the one side and 5 days everything new on the other side. So there always is a certain overlap or things that are not necessarily directly to be solved. Based on these 3 principles, the whole family of SUSE Linux Enterprise is built. We say here base OS and modules because this is the big overview slide which you need a magnifier for to read it. I apologize. But we wanted to have a really single view on the whole family of SUSE Linux Enterprise 12 and 15 in this case. And one thing that you see very nicely here with the bullets in the upper lines is that we have the plan to deliver every year a new service pack for SUSE Linux Enterprise for the respective code stream. So there is SUSE Enterprise 12 in the second half of last year. There will be SUSE Linux Enterprise 15 mid this year, and there will be SUSE Linux Enterprise 12 as before end of this year. And the same thing next year, more mid of the year, there is planned 15 SP1, and end of the year is planned 12 SP4. And another thing that you see here as well is that obviously the innovation on 15 is much higher than on 12, but that's normal because on 15 with the newer code stream, we have more options to build in newer technology. The 4 themes that we have chosen for 15 specifically, so these 3, let's go back to these 3 points. These are across all versions, right? Increasing uptime, operational efficiency, and accelerating innovation is things that are guiding us through the whole family and all versions of SUSE Linux Enterprise 15. For SUSE Linux Enterprise 15 itself, specifically, there are 4 major things. Number 1 is the multimodality solved in a way that it scales also into the future. And 2 things that help with that is number 1, the unified installer. This means that we can install all SUSE Linux Enterprise 15 products from one installation ISO. So you do not download an ISO for SLES for SAP, the desktop, and the new HPC product anymore, but you have one installer. It's the size of less than a CD. That was one of the goals that we also had. Even if nobody uses that anymore, it's a mental goal that we had. We want to fit it on a CD again, and it does. And so you can download this CD virtually and install all the products from there. And you can also download a second ISO image, which then contains all the rest of the packages, so that, and this is a benefit, what we did not do with 12, you can also have a full offline, disconnected offline installation of the product. I think this is very important for many infrastructures which are disconnected from the internet, or where you have a so-called sneaker firewall, which is the most efficient one actually. And you see that currently in Germany, that if you do not have a sneaker firewall, but something which is not sneaker, but differently, that there is always a way to sneak things in, right, or out. So the unified installer is on the heart of SUSE Linux Enterprise 15, and it drives a lot of other things. It drives that we have to be more modular because we want to do this Lego approach of putting products together out of existing modules or entities. And one other thing which is obvious in this case is that we do not want to bother you with all these modules. Yes, you will see them. Yes, you can choose what module you want or need so that you are not overwhelmed. But there is a certain need for ease of use that we have to apply to the product so that you can find things, that you can easier install things. One thing that we have already online is that you can search for packages in SUSE Linux Enterprise and see if they are available for SUSE Linux Enterprise, because many people ask us, why is package ABC not available for SLES? Well, actually it is, but it's in the HA product, for example. Someone is looking for a specific thing that SUSE delivers as part of the high availability stack, and then people complain that we don't support this. We do, actually. Now, with the new approach, online search, you can find it, and if you have your system installed and connected to the internet, so no sneaker net firewall, then you can also search on the command line, because it's directly checking back on our SUSE Customer Center and using the same search functionality. Don't call this big data, it's easy. Another change, and this question comes very often, this is why we have this slide, another change in 15 obviously is the kernel version. We will not change the approach of changing the kernel version every second year. This will remain. We have well proven to all of our ISV partners that the certifications remain stable, and this really helps to accelerate innovation. Remember that topic. Accelerate innovation on the hardware integration part. But for a new major version, we obviously take also a new major kernel. Now you may wonder, why aren't you taking kernel 4.15? A, it would fit from the number, and B, it would fit from the timeline. Actually, it would fit from the number, but it doesn't fit from the timeline. Because one key aspect of building an enterprise Linux distribution compared to a non-enterprise Linux distribution, which comes out in April, is that we need between 8 and 12 months to harden the kernel. And harden the kernel is not only meant with respect to security aspects, that's another aspect, specifically in this year, but what we need to do is to find out all the performance bottlenecks which may be in an upstream kernel. Because the upstream Linux community cares a lot about a lot of things, and we appreciate that, and we are part of this community, but they are not measuring so detailed as we do. They are not measuring on all architectures. They do not see all the results of things. To give you an example, we have, you know that SUSE loves UpArmor, this security confinement technology, and we have found that the specific enhancements in UpArmor in the signal handling, so confining the signal handling of an application, has a really bad impact on the performance of specific applications doing massive signal handling. Now you could say this is a fault of the application, which is partially true, but nevertheless, at least knowing about this and then finding ways to potentially improve this by just a few percent in a micro benchmark is something that we think is our responsibility. And so these are things that need 2 or 3 months to develop and to be found out and to be developed and then to be brought into the product. And this is the reason why we are using kernel 4.12 and not kernel 4.15 for SUSE Enterprise 15. We had used kernel 3.12 for SLES 12 because it was timely and a better shape. So there are a few things that we do here. Probably one of the things that I should mention is not actually on this list, but on a later list of things that we improve, but I would like to mention it here. Who has heard about NVDIM technology? Not many. Okay, so NVDIM is non-volatile RAM technology. This means that the main memory that your system is using is not deleted when you are switching off your system. This has a benefit that you do not have, you could think about it a little bit like a flash disk that is not a flash disk but is your memory in the same time. And what this is, the benefit is if you have really huge memory, like for in-memory databases, and there is a famous product called SAP HANA doing this. I don't know if SAP is working in this area, I guess so. Then you need about 40 minutes to even load the data from the disk into the memory. You have to load from the disk and you have to put it up into your memory. This takes time. in a system with non-volatile RAM or non-volatile DIMMs, that's the hardware, you do not load from disk to memory. But what you do is you switch on your system and you tell your memory, okay, you are now my memory, and you know that your data is already in that memory, because before you switched off your machine, all the structures of your database were in this memory. So you're just switching on, making it read-write, and you have your memory attached. You do not write to disk. You just compute in memory completely. SUSE already has implemented this technology in SUSE Linux Enterprise 12 SP3. We have a famous benchmark there, together with the Microsoft SQL Server on Linux on HPE hardware. So if you want to search for that, it's something we are very proud about, because it shows that SUSE is really a technology leader. And actually it shows one thing about Microsoft here today. It shows that Microsoft really understands how Linux works. These packages for Microsoft SQL Server is the best commercial RPMs I've ever seen. Really, if you look at it, it's free for download. This is just so clean, and the installer is so straightforward. That's fun. So we have done this NVDIMM technology, and there is new NVDIMM technology coming out. We are working with our hardware partners to enable this. SUSE Enterprise 15 will have this enablement, and because this is so great technology, and because this kernel will be really great, we will also use this kernel for SUSE Enterprise 12 SP4. So that's the first time ever that we are sharing a kernel between two code streams, which means that the real difference between code streams is not on the kernel level. I think this is very obvious now. But the real difference between code streams is on the level of shared libraries, how the system is set up, and all these things around. So glibc, for example, and so on. Other things that we have in 15 is the GCC7 as the base compiler. Who knows what the base compiler in 12 is? Nobody? 4.8. So it's really ancient. The GCC7 will be the base compiler. And as we have done with SUSE Linux Enterprise 12, we will also continue to ship a new GCC every year as part of our developers module. Another aspect of the modularity, that we can ship a second compiler in a supported way. We will build a new OpenSSL, and actually this OpenSSL is very clever because it will be an OpenSSL that we can upgrade over time. In the past, that was not possible due to frictions in the community, constant changes of the application programming and application binary interfaces. The new OpenSSL is much more stable, and we are adding an additional step here, which is called symbol versioning, so that you can really update the OpenSSL without breaking backward compatibility. That's one thing we have to get and say that the Debian community has done very well, and we're using the same technology that the Debian community uses here with respect to symbol versioning for OpenSSL. It's obvious that we will upgrade the scripting languages, but I have a question here, which actually is an open discussion currently. Who uses Python? Who uses Python 2? Seriously? Why? You use both? Okay, good. Because, so we will definitely deliver Python 2, but there currently is the question if we deliver Python 2 in the base operating system or in the legacy module, where the legacy module would tell people it's going away in a few years, while the base operating system would tell people it's supported for another 13 years, which I definitely do not want. So, yeah. Okay, not so many people. I expected more people. Good. In the high availability area, there is one other change that is not listed here, but that is an important one for everybody who uses geoclustering and thinks about that. We currently have a separate product called SUSE Linux Enterprise. No, it's called SUSE Linux Enterprise Geoclustering Extension for SUSE Linux Enterprise High Availability. is the longest product name that SUSE or Micro Focus ever had. And because A, the product name is too long, second, the construct of having an extension to an extension is totally ugly, and third, we want to make it easier for people to use that. The geo-clustering will now be included in the high availability product per se. We're currently discussing how we do that for 12. That's a little bit tricky with dependencies and so on. But for 15, you will definitely get the geo-clustering included into the high availability product without price change, actually. So we are also modernizing other pieces of the stack, mentioning Crony here and Firewall D. The Firewall D is a little bit the tears on this, in the SUSE eyes, because we had our own firewall solutions called SUSE Firewall 2 for about 15 years, but it was a crappy shell script, which now goes away in a very nice way to an open source and upstream project. I already talked about the NVDIM support, and one other thing is we definitely will do security certifications. You see FIPS here, that's an American standard, but it's also relevant for Europe in the financial industry sometimes, or for government or military. If you interact with colleagues in the US, then FIPS is a need. And we also plan a common criteria certification for SUSE Enterprise 15, most probably with the BSI in Germany, because they deliver a very good quality there. Since we have done, so this is basically the overview about 15. If you have some questions, I think we should do that now, because I have a little bit more to add. Yeah?
Why 15? You already skipped numbers. Why 18? Because it would be...
Yes. So, we originally wanted to call it 13, but there have been questions raised from all over the world regarding the numbers 13 and 14. 13 is a bad number in number of companies in Europe. 14 is a very bad number in China, which obviously is also a big market. So there was the decision that we go for 15 because that is a safe number to go. And that is the problem with 18 is that in 13 years, when it is when it's end of life, who will understand what 18 meant? So we really only skip these two and go to 15. That's the whole thing about the numbers. Okay. It's a good question, actually.
I still know, like Windows 95 was 95.
But Windows 2000 came out in 2002, so that's a little bit. Other questions? Nobody? Okay, good. Another thing that we changed since we did /12 is actually how we interact with the community and also with our customers. So there are multiple things that we have done. Number one is we have invented or given away the code completely for SLES to the community now, not given away, but published it. It's available to the community to work with it, and the community builds OpenSUSE Leap out of it, the same stable code that we use for SLES. The difference is in the support commitment, obviously. The difference is that the community changes some things on top of this. They are allowed, obviously, it's all public, open source. And nevertheless, there is a very good mutual collaboration. Thinking this further, we decided that for starting with SUSE Enterprise 12 SP2, but obviously also for 15 now, we have a public beta program, so that you just need a SUSE login to participate in the beta program. No registration, no filters by a stupid product manager anymore, but just if you have a valid SUSE login, then you can participate in the beta program. And we have seen some benefits of this. I think we got from about 100 people to over 500 people participating in the beta program, which is quite significant because people also have other things to do than doing beta tests for us, right? But we like this, and we also like that the OpenSUSE community works together, and actually this co-working with the OpenSUSE community has also other consequences, because there is a technology called Open Build Service, and I would like to talk about this quickly. This is the heart of how SUSE develops. All the SUSE products are built in this technology, and we have an internal instance for our enterprise products because there are common criteria certification, specific measures that we have to do with respect to code review and so on. And we have the public instance, which is called Build OpenSUSE.org or Open Build Service. And in this, all the OpenSUSE distributions are developed exactly with the same technology and the same methods that we are using internally. Now, given that all these packages are already there, and that this Open Build Service has about 22,000 open source packages in there, but SUSE Linux Enterprise only has 2,000, we thought it would be cool if our SUSE Enterprise customers could also use a little bit of this community. So we give back to the community with the quality, with the source code, with the infrastructure, and so on. And what we also did is we have a small team which helps community members to build open source packages for SUSE Linux Enterprise. 12 currently, but 15 will also come. This is how, for example, the Chromium browser is available for /12. KDE is available for /12 because we don't support it officially anymore. The R language is available here. Haskell compiler is available. That's just a few examples what is there. And this is what we call the SUSE Package Hub, so that we have upstream packages in the Open Build Service provided also to the enterprise customers. So quick view on this build service. It's a complete workflow from source code to either an RPM or an ISO as a distribution, or in the most recent version also a container. So you also can produce directly a container, which again closes the loop to our software-defined infrastructure. And with that, I would like to finish actually in time. Let's finish here. If you have other questions, I'm here the whole day. Actually, until tomorrow morning. The latest question you can ask me personally is tomorrow at 4 o'clock. And with that, I would like to get more questions or discussions over coffee later.